Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. So my name is Muhammad Amirul Amin bin Kamian. My matric number is AN190087. My supervisor is TS Muhammad Fadli bin Abdul Razak. So I would like to present about my bachelor degree project 1, which is the title is Research Performance of Lead Acid Battery for Off-Grid Solar System. Okay, for the first chapter is Introduction. Okay, so in solar system, lead acid batteries are the most popular form of battery other than lithium-ion types of batteries. Despite their low energy density, low efficiency, and high maintenance requirements, lead acid batteries have a long lifespan and low cost when compared to other battery types. So lead acid batteries have the distinct advantage of being the most widely used type of batteries for most rechargeable battery application. For example, starting car engines. So lead acid batteries has its own state of charge and depth of discharge, which is DOD, which is the different from other types of batteries. Furthermore, each element serves a purpose and can influence the solar system's performance. Okay, for lead acid batteries, there are two basic ways for determining the state of charge, which is SOC, which is terminal voltage and specific gravity. For the depth of discharge, lead acid batteries should be discharged only by 50% to increase its life, which means they should be cycled in the 100% to 50%. Okay, for the next part is the problem statement. So basically my research have three problem statement. First and foremost is the SOC and DOD. For lead acid batteries, the maximum depth of discharge is usually at or below 50%. The DOD is significant because keeping to it offers the battery a longer lifespan. To avoid needing to discharge lead acid batteries below 50% of SOC, the nominal capacity of the batteries must be improved. Okay, for the second problem statement is the lifespan. Lead acid batteries life expectancy can range from 3 to 4 years, it depending on the load. It is because after charging, lead acid batteries need to be cooled down since the charging process generates lots of heat. So the last problem statement is the effectiveness on the solar system. So lead acid batteries are less effective charging batteries other than another solar batteries. One of the causes of lack of effectiveness is the internal corrosion, sulfation, and loss of electrolyte. For objective, there are four main objectives for this research, which are the first one is to identify the properties and capabilities of lead acid type batteries on the solar system. So the second objective is to study the effectiveness of the lead acid type batteries on solar system. So the third objective is to assess the level of charging and discharging of batteries using the solar system. The last objective is to comparing the differences in the analysis of lead acid type batteries with lithium ion type batteries. So the next part is the scopes of the project. This research is focused on the lead acid batteries performance for solar system. Therefore, this system will cover the scope as follows. Okay, the first scope is learn and find information regarding the nature and capabilities of lead acid batteries if used in solar system. The second scope of my research is to study and analyze SOC, DOD, and effect on the battery during the charge and discharge process done using solar system. The last scope of my research is analyze the capability comparison between lead acid type batteries and lithium ion type batteries. Okay, this is the chapter 2, which is the literature review. Okay, so this is the table of comparison of previous project that related to my research. So as we can see, I can find 4 related project, and I literally focus on a 4 related 4 previous project, which the title is a comparative study of lead acid batteries and lithium iron phosphate batteries used in microgrid system. It is because my partner and me is comparing the lead acid batteries and lithium iron phosphate, which I will analyze the lead acid batteries, and my partner will analyze the lithium ion phosphate batteries when we connected to the solar system. Okay, this is the chapter 3, which is methodology. In this chapter, the process of completing the analysis for the performance of lead acid type battery for solar system was made to ensure that the research can be complete and implemented smoothly before any action is taken on to the research. Okay, this is the final year project flowchart. Uh, okay, so this is the block diagram for my research. The block diagram for my research, which consists of solar panels charging the battery via a charge controller. The charge controller is in charge of energy dissipation. A controller, on the other hand, has no effect on the discharge characteristics of a battery in the operational range. And it only operates when the SOC reach the extreme ends. There is 2 options of the output, which is AC and DC output. The DC output come direct from the solar charger controller to the load, while the AC output is come from inverter. Okay, this is the flowchart for my research. So for the starting, I will do the literature review, which is I find the related previous project, which related to my research. After that, I will do the selection of lead acid battery for my research. After I select the lead acid type batteries, I will research and explore about the detail of the type of lead acid battery that had been chosen. After that, I will do the result analysis for the lead acid batteries, while my partner will do the result analysis for the lithium ion battery. So basically, the 2 type of batteries will analyze when it connected to the off-grid solar system. So the next part is the process of comparing the result analysis between the lead acid battery and lithium ion battery. If accepted, we will do result analysis for the battery that had been researched. If not, I will select of the lead acid battery. uh, I will select the other type of lead acid battery. Okay, this is the design planning for the research. In this particular setup, the solar panel is responsible for soaking up the sun's ray and then passing that energy on the solar charge controller. This is because the solar charge controller acts as a function that regulates the voltage and current flowing from the solar arrays to the battery to avoid the battery being overcharged and overdischarged. The voltage source will then be stored in a battery that is lead acid battery. Lead acid batteries are the focus of this research. The next part is the performance characteristic of the battery, such as its state of charge and depth of discharge will be evaluated. The battery in the device that store the voltage source in DC voltage. Before transfer to the load, the inverter will change the DC source into an AC source. To take safety precaution, the source from the inverter will go through the circuit breaker first before being connected to the load. This is one of the safety precautions in the circuit according to the specification of the circuit breaker and load. Without an appropriate specifications, it can cause load damage such as overcurrent. Okay, for the next part is hardware devices. For solar panel, I choose monocrystalline silicon solar panel, which is mono Si. It is because it uses sunlight to generate electricity and supply it to lead acid battery that for solar application on a larger scale. After that, it manufactured from a cylindrical silicon ingot. After that, the monocrystalline silicon solar panel is highly efficient solar panel that diffuse with phosphorus at the top of the surface. Last but not least is this solar panel with a power output of 50 watt to 100 watt, ideal for power high voltage appliance. So in the right side is the specification for mono Si solar panel. Okay, so this is the most important part for my research. I chose silver acid battery, which is SLA battery. So in the left side is the specification for the SLA battery. Why I choose this battery? Because the normal absorption for voltage for SLA battery range is 14.2 volt to 14.7 volt. So this battery have a lot of advantages compared to other type lead acid battery due to its maintenance free, which is there is no need to top up the electrolyte. The third one is lead acid battery can survive anywhere from 300 to 1200 cycles. The last one is the self-discharge rate of the SLA battery is normally around 3.3% each month. Okay, the inverter that I chose for the research is the pure sine wave inverter. It is because 100 watt pure sine wave inverter are chosen to use to complete this research. This is an electrical devices that convert direct current DC to alternating current AC. It does not generate any electricity instead of the DC source provide it. So the next one is the pure sine wave inverter needs a somewhat stable DC power source capable of delivering enough current to meet the system's desired power demand. Okay, the last part is the input voltage is determined by the inverter's design and purpose. So this is the solar charge controller that I chose for my research, which is a 100 watt MPPT solar charge controller. First and foremost, the rating users for this component are 12 volt DC MPPT solar charge controller, which LCD display, and 5 volt 2 ampere USB output. The second one is it regulates the energy flowing from the solar panel array and transfer it directly to the batteries. The third one is MPPT charge controller is a DC-DC converter that boosts a solar system efficiency. Okay, the fourth is it will be giving batteries as long of a life as possible. Okay, this is for Gantt chart. As we can see, this is the Gantt chart from week 1 to week 14. Okay, the last part is the reference. So this is the all of the reference that I chose to make my research, and thank you.